Hello, welcome back. We're going to continue talking about this concept of vertex and axis of symmetry. This problem that I'm going to give you is going to be a little more challenging, mostly because of the fractions involved, but I want to show you one that's a little more challenging so that you know what to do. Let's say you have the function f of x equals negative x squared minus 5x plus 6. Now before we go any farther, we want to label. What is a equal to? Well, in this case it's negative 1. B is negative 5, and C is equal to 6. That's just A, B, and C that we've had and been dealing with this whole time. Now, from the fact that A is equal to negative 1, you should immediately know that this is going to open down somehow. There's going to be a frowny face, I should say. It opens down. So we can certainly create a table, but this, as you will see, is going to get cumbersome to calculate a bunch of points, so we're going to do it a slightly different way. First of all, let's find the vertex, which is what we always want to do when we plot these things, because it's the most important point on a parabola is the vertex. It's where the thing bends over and starts going the other direction. So let's find vertex x, the x-coordinate of the vertex, is always negative b over 2a. So it's always negative. Now b, in this case, is negative 5. You can see it right there. So the negative 5 has to go on top, 2 times a, but a is also negative. You have that on the bottom. So really what you have is, if you multiply this here, you'll just have a positive 5, and on the bottom you have a negative 2. So negative 5 halves. Now that is the x-coordinate of the vertex, but whenever you're plotting things, it's better to have mixed fractions. You know, for instance, if you want to go 1, 2, and a half, it's easier to do that. So how do you convert this to a mixed number? 5 divided by 2, it only goes 2 times with 1 left over 2. So we're just converting this mixed number into, this improper fraction to a mixed number. Now you see, when we have negative 2 and a half, that's easier to plot. Negative 1, negative 2, here's negative 3, so negative 2 and a half is somewhere right there. All right, that's vertex x. Now how do we find the y component? We just take what we found for the x-coordinate of the vertex and we plug it into our function. So for vertex, the y-coordinate of the vertex, we just plug it in. So we say f of, and we could put the negative 2 and a half in there, that's fine, but we're gonna put the improper fraction in here. We'll put negative 5 halves, and we'll stick it in here. And it's gonna be a little messy, I'm not gonna lie to you, but we're gonna work through it. So we plug it in, negative x squared, but in this case it's negative 5 halves squared, minus 5 times negative 5 halves plus 6. So now we just calculate things here. What we have on the inside is the square applies to the top and the bottom. The negative times negative is positive. So we still have that negative on the outside, but then we'll have 25 over 4, like this. And then here, 5 times 5 is 25. This negative times this negative is positive, so we make it a positive 25 over 2. And then we have plus 6 here, but I'm going to write it as 6 over 1. And the reason I'm going to write it as 6 over 1 is because we have 3 fractions, and we have to add them all together, and they all have different denominators. So I write it as 6 over 1. We need to make common denominators. So what I'm going to do is multiply this one by 2 to give me 4. I'm going to multiply this one by 4 on the top and bottom to give me 4. So let's go ahead and do that work right now. And what we're going to have is negative 25 over 4 plus 25 over 2. But now I'm going to multiply top and bottom by 2. And then finally over here I have the 6 over 1, and I'm going to multiply top and bottom times 4. And I told you this would